Okay, so last class I was telling you about the different types of method modifiers like static, final, and abstract we were discussing in. Okay, now let us move on with what we call it as an interface. Then we'll discuss how it is, everything is going to be there for us. Okay, so I'll start. I'm starting a new. So I want to have the interfaces to be designed that we'll discuss. Okay, now I'm creating a class only with the main method. I'll create the class. So I'm trying to create a class, select the class type, then next. Now it asks me what is the name of the class that you're going to define. So I want to create a class called tinter. So I mean, it's an interface, testing of interfaces. That's what I mean to say it is. I want to have a main method in this. I'm selecting a main method and then I say finish. So a class is created for me called tinter, in which my main method is going to be there. I want to talk about the interfaces there. Now we'll discuss what is this interfaces are all about now. So what is an interface for me now? The last class I was just telling you, the last session I was telling you about the abstract classes. When you talk about the interface, we said in the abstract classes, a class is said to be an incomplete class where we said that we are going to have, just let me have a revision of this. Okay, we said in case of an abstract class, the methods will be defined as of the type what you call abstract. When you say the methods are going to be what you call the abstract, it means we have only signature of the function will be there, or method signature will be there. So for example, like this, okay, we will not be having the body of the function will not be there, or what you call the implementation we call it as. The definition, the code part will not be there for the method. So in case of the abstract class and in case of the abstract method. So if I'm going to have any abstract method is going to be there in a class, then you have to define them. The class also has to be defined as an abstract. Remember, when you talk about the abstract classes, you can have um, a function with the body and without body, both are allowed for you in case of the abstract class, right? Uh, an abstract class, as you said, is an incomplete class. It's a class where we can also have the normal variables also can be, you can have the field variables, fields we can have it, or what you call the properties also can be defined as a part of the abstract class. But when you talk about the interface, okay, so in the interface, we'll have the methods are there. Okay, methods will be there. Sorry. We have methods without body. Okay. Or what you call we have methods. Only method signatures will be only method signatures will be there for me. So we'll have the signatures alone will be there. That means only declaration will be there for you. Body will not be there in case of the interfaces. Now remember, interfaces they look similar to that of the abstract classes, but only thing is what in case of the interface we will not have the methods with the body will not are not allowed for us. Whereas in case of the abstract classes, it is going to allow for me to both to have the methods with the body as well as methods without the body. Both are allowed in case of the abstract classes, but in case of the interfaces, we have only methods without the body. That's only signature part will be there. Now, can we have some variables inside this? Yes, you can have the variables also, but in case of the interfaces, the variables what you're going to define are of the final variables. There are going to be static final variables you're going to have it. That means the value of just the variables what you're going to define or what you call um, the property that you're going to define inside the interface, they cannot be modified further. Okay, and let us see how we discuss this. Now, how we define the interfaces? If I want to define the interface, we are going to use a keyword called interface. Like as a class, you are going to define. When you are going to define a class, you are going to use the keyword called class. Like that, for the interfaces, we use a keyword called interface. So followed with the interface, you will be defining what is the name of the interface that you want to have it. Okay, for example, let us say that, so I want to define an interface called marks I want to define. Okay, I'm defining an interface called marks I'm defining it. Okay, so where in the marks interface, I want to have a method which is going to do the calculation of the result. The same one, I'll take the example of the previous one, I'll take it. Okay, or we'll take one more example, we'll take. So I'll do one thing, I'll open my PowerPoint brush, I'll open, or I'll use a different option, I'll use. Give me a minute. Okay, so what I want to do is, so we want to define a class called shape class. We want to have it. Okay, so we want to have a class called a shape now. Now, when you say a shape, so can you tell me one example for the shapes? A shape, can you tell me? What's a shape? One example. What is a shape? One example for the shape. No? Okay. So we have the examples for the shapes like circle. Maybe it's a rectangle. Okay. Maybe it's a square, right? Okay. Now let us say you want to write the program for the shape. Now, when I'm talking about writing a program for the shape now, so the different types of shapes I can have it. That is circle, rectangle, whatever wheels or square is. Now, when we talk about them, let us talk about the shape called circle. If I want to define something about a shape called circle there, then remember when you talk about the shape called circle, now if I want to draw a circle, okay, so I need some parameters are required to draw a circle. What are the parameters that I need to draw a circle means? Okay, so I want to draw a circle. So I require radius. If I want to draw the circle, I require the radius part. Now remember, not only you need the radius part, you also need the center point where the circle you're going to, what is the midpoint of the circle? So I need the midpoint. Okay, I need the midpoint of my circle. Okay, right. Now I want to calculate with using these things, right? I can also calculate the area of a circle. So I can also calculate the area there. So how do I calculate the area of my circle? We are going to use a formula pi r square. We are going to use it. Okay, so that is I'm using pi into r. I'm going to use a pi r square. Okay, that is something about your object called a circle. Now let us say you want to have one more object, right? Called rectangle. I want to have it, right? I want to have rectangle. Now, if I want to draw the rectangle, what are the parameters that I want to require? I require them. So I want to draw a rectangle. Then the parameter that I require is I need to know the length of my rectangle and the breadth of the rectangle are required. Okay, I need the rectangle length and the breadth are required for me. Okay, as well, I need to know what is the starting point of your where you are going to draw it. Okay, so you call it as the starting point. So which we call it as the XY axis. Okay, so it is same as that of your circle also. For the circle also, we need to have a center point is required. But whereas for the rectangle also, we require the point from where you are start the rectangle is going to draw it. Now, I want to have the area calculation has to be done. So how do I do the area calculation part? So for that, I require the length value and the breadth value are required. I need to multiply the length value and the breadth value has to be multiplied. I get the area. Okay. Now, one more shape we are discussing about square now. So I want to have the one more square object. I want to have it. Okay. We want to have the object called a square. So for the object called a square, the same, almost the same parameters are required for me. I mean, when you talk about the square, slightly different, sorry. Okay, I want to draw a square now. Okay, I want to draw a square. So for the square, you require what? The side value is required. What is the side for it? And then we also require the midpoint. Okay, or what you call the xy, the coordinate points where it is going to start for me, xy is required. Then using these things, like I can also what? Calculate the area. Area can be calculated. So we know that the area for a square is s into s it is, right? Okay. You able to understand what I'm telling now? We are going to have the different types of objects we are going to have it. Okay. So different types of objects you're going to have. So one is, give me a minute, sorry. Okay. So I need to have, this is my object. This is one class for me. So there is another class called rectangle I'm drawing, and there is another object I'm going to have called square. So three different objects I'm going to have it. Okay. Now let us say that I want to write a program for this one. So I want to write a program to create this for the circle object. I want to write the code. So then, so I'll be defining class. Okay, let us say class name. Then you're going to have what are the things are required, what are the variables are there, or what you call the what are the properties you're going to have it, and what are the methods you want to have. All like that you can define it. For circle you define it, for rectangle you define it for the square. No, this in you'll be writing like this individually. Okay, when when I don't know the concepts of inheritance. Okay, so when I don't know the concepts of inheritance, if I don't know, then so this is the concept now. 1 minute. This will be doing it without the inheritance for us. Okay, so without the inheritance part, I'm writing like this. Now, when I know the inheritance, we said what? So how we going to do it? What you call inheritance? So we said in the inheritance, what we are going to do is, what are the things that are common for me that will be removing it and will put into a different class. For example, you talk about this one, the class. Now you talk about this, what you call a circle. So in the circle, so we are having something called radius is there, a midpoint is going to be there. That whereas when you talk about this rectangle, length, breadth is there, and then midpoint is there. Okay, what you call the starting point. The square you talk about, we have the side value xy is going to be there. That means, so when I'm talking about this, the square, when I'm talking about the circle, there is something common for me. No, there is something common for me. There's a midpoint is there for this. So for this, I'm having midpoint. Then for this, I'm having x and y. These three are going to be common for me. And if you look in there, more of the things, the actions that we are going to do, the actions are nothing but what? I'm going to have the methods like draw a circle. This is one of my action. Okay, one more action I'm having draw the rectangle or the area calculations I'm going to have it. So the methods I'm going to have like drawing the square, then calculate the area. The methods are going to be there. Now we know that when you're talking about the inheritance part, whatever that the things are common for us, that will remove it and we'll put it to one class, and then we use that particular class to define the next set of classes that we define it. Okay, so when you say that, so it is, so using the inheritance now we'll see the concept of how we are going to do it using the inheritance now. Now, so now let us talk about this one, we using inheritance. So using the inheritance, we'll talk about now. So when you say that using the inheritance, what we will do is, what is common for us that will be removing and we'll create one class. Now for this, So I'll be creating one class over here. So what is the class name that I want to have it? So it's a common name I want to have it. So what I do is I'll take a name like what you call shape and create. Okay, so I want to have a class called shape. I'll be creating it. Then when I'm creating a class called shape there, okay, so here what is common for me? The x-axis and y-axis are common. So I will take the properties. So the properties, okay, what are common for me? So x and y are common. I'll take only x and y. I will take for this. Okay, so what about the methods for me? So when I talk about the methods now, so methods are nothing but the actions what you're going to do it. Okay, so what are the methods that I want to have it? Now draw. Okay, so draw we are going to have it, and then area. Now remember, now when you talk about the shape, so when you talk about the circle, you know how to calculate the area of a circle. When you talk about a circle, I know how to calculate the, I know how to draw the a circle. But when you talk about the generic thing, like what you call a shape, you are going to talk about. So we cannot define how to calculate, I mean, the area of a shape or how to draw a particular shape. We don't know. When you say that an example called circle, if I'm saying that, you know how to draw the circle, you know how to calculate the area of a circle, but you don't know how to calculate the area of a shape. So shape is a generic now. It's a generalized one. I don't know how to do it. Then what I do is, so it is better what I do is now here, I don't know the way how the thing has to be done for a square, I mean, sorry, for a shape, I don't know. Then what I do is these methods, what I'm going to have here, so these I'll make it as abstract. Okay, I'll make them as abstract. So what do you mean by abstract? That means I'll tell that the function, whatever the function that you're defining, so those functions will be there in my class, but their body I don't know. That is, I don't know the implementation. That is, I don't know how to calculate the area of a shape. I don't know. Then what I do is I'll make it as an abstract there. Okay, then once I make this one as an abstract, then what I do is I'll create a class, okay, called rectangle class I will take, or I will take a class called circle class I will take. Okay, I'll define the class called circle. From the class called shape class I will take it. And then what I want to do is I will tell that, so what is the required extra things are required for me. For circle, when you look into the circle, what are the extra thing that is required for me is, okay, I have taken the midpoint. Okay, I have taken the, okay, I have taken only the midpoint xy, I have taken it, right? Okay, then I have defined the method, but I don't know how to calculate them. So what I do is here in the circle class, I require the extra thing is what you call the radius. The property radius is required for me. And then here I'll be defining, so how to calculate the area calculation, you'll be defining it. And then you also define, so how to draw the circle. Okay, we also define how to draw the circle. Evidence of what I'm telling here. So in the class which you're going to define, so there we'll be defining it how to do things. That means when I'm defining this class called circle, so okay, the class called circle is defined from this class, what you call the shape class, I'll be defining it, right? Similarly, so what is there required for me in the rectangle class, you'll be defining it. In the square class, what is the things that are required, that will be defining it for the square. Okay. These things you can do it using what you call the abstract classes. We can do it. We'll see how to write the coding part for this one. I'll jump to the coding stuff. Okay. Now I'll not take this interface. I'll take one more. I'll take this. Okay. We'll talk about first. We'll talk about the abstract class. Then we'll talk about the interface. We'll talk about. Okay. So I'll take the abstract class called shape. Abstract class shape I'm defining. Okay, in the abstract class, see, time being, what I'll do is I will not take the xy. Okay, I'll not take the xy. So because I'm not going to implement the drawing part, I'm not going to implement. I'm talking only about the area part. We'll talk about. Okay, so we'll not talk about the xy values. We'll not talk about. Okay, Now here I want to have a method. So the abstract method I'm talking about. So, okay, the abstract method, I'll take it as a main, the method returns me an integer value. So if you want, you can define the integer value, or if you feel that the method is not going to return anything, then you can define it as void there. Okay, now here I'm going to have a method called area method. I'm defining it. So I said abstract void area, I'm defining it. So from this class called shape, I want to define a class called rectangle or square, whatever it is, the circle object you want to define. Now I want to create the class called circle class from the class called shape. So I'll say it extends the shape there. Now remember, when I'm going to use my abstract class, if I'm going to use it, then you'll be using what extends, will be using it to create a new class. Now we know that in case of the abstract class, whenever there is an abstract method is going to be there in an abstract class, the abstract classes instances cannot be created. That means you cannot create an object from the shape class. Why? Because it's in an abstract format. But whereas I can create the instance of the subclass, like that is a circle class, I can create the instance can be created. Okay, if in case if I'm not defining the method, the area method which you are defined in the base class, it's not defined, or that is its implementation not done in the subclass, then subclass also becomes an abstract. It has to be defined as abstract, where you cannot create the instance of the circle class. Also, you cannot create the instance if you are not defining the abstract method which is there for me in my base class. Now here what I do is I'll define the method now. Void area method, I'll be defining it. Okay, area method I'm defining, and then I'll write the code for this one. I'll be telling how the area has to be calculated. So for calculating the area, I require the radius. Okay, I'll take here the integer value radius. Okay, right. So how do you calculate the area? I'll take a variable called float data type. I'll take, so area calculation AR, I'm taking a variable called AR there. So which is equal to, how do you calculate the area? It's a pi r square for me. So when you say pi r square, so I don't know what is the value of my pi there. So then what I'm doing is I'm making use of and the built-in class, what you call a math class. So in the math class, we are having a property is there, what you call pi. So pi is a property which is available for you for to find out the value of a pi value there. Okay, then I'm writing math.pi, I'm writing. So when I say math.pi, automatically it takes the value of the pi. So we know that the value of the pi is going to be 22 by 7. Okay, it's a 22 by 7 where the value is going to be converted to 3.14 something, right? So either you write math.py, you write it, or you can replace it using 3.14, you can replace it. So as you wish. So whatever you want to do it, you can do it. Okay, math.py into radius into radius. So I'll have the variable value, it's called radius into radius. Okay, radius into radius. So that is how you are going to calculate the area part there. Now here remember, when I'm going to use this the area property, what I'm doing here is I'm using the data type called float here, but my math value, when I'm using math.py, so that is going to return me the double value. So when I'm getting the double value, I'm trying to store in a float value. That means I'm storing in a value where it's of lesser precision for me. Okay, it is a less precision. That means accuracy is going to be less in case of the float values. What do you mean by less precision? Means a float can store for me up to only 6 decimal points, 6 digits after the decimal point. But whereas when you talk about the double, so double is having a higher precision. So it will be using 12 digits after the decimal point for the calculation. So double has the higher precision and float is having the lower precision. So when I'm doing like this, what happens is in your Java, it gives me the error saying that you are trying to lose the precision. There's a loss of precision is going to be there. That error will be getting it. Okay, I'll explain you that error again. So when I'm going to work out with the example. Now you can also see that that's what it is also telling you. So there is a mismatch. They cannot convert from double to float. Okay, it says that you cannot have the double value cannot be stored into float, it says, right? So if you want to avoid that one, what you can do, there are two ways of doing it. So one is you can use the typecasting can be done. That means what? So you're going to narrow it down. That means I'm converting from a higher precision, that is my double, to lower precision, what is called float, right? So you can have the typecasting can be done. So for doing the typecasting, you're going to use the typecasting called a float. So you put the values into parentheses, you're going to put it. Then, so you're asking to convert the value to the float and then to store it. Then it understands it, okay, you want to downgrade it, or what you call, you want to have a lesser precision, or you need to convert from double to float, you want, sorry, from double to float, you need to convert. So it does a narrowing, it's going to do it for me. So, okay. Now, if you don't want to this one to be happening, so I want to have the alternate code for this one. So I'll just put this one as a remark in the alternate code now. So when I want to have an alternate code, one simple method what you can do is you can have it as double. You can take the data type as double. So when I'm having the data type as double, then it is not required for me to convert the float. Okay, the typecasting is not required if I'm going to use it as double variable. Okay, like that. And then, so in this method, I want to print the value of the area. Then, okay, I'll just call the system dot out dot println. Okay, so I'll use printf. I'll use, instead of using println, I'll use printf. Okay, area of circle is equal to percentage. So double, right? Okay, percentage f can be made use of, no problem there. So comma, okay, AR I'm writing. So I want to have the number of decimal points I want to decrease. So I'm writing 0.2f, I'm writing there. When I'm writing 0.2f, that means what? Instead of printing 12 digits after the decimal point, it will cut down to 2 digits after your decimal point when I'm using 0.2f there. Okay, this is how we are going to define the shape class, right? So for the shape class, we are done. The abstract method, we are defined it. And when you talk about the circle class, so in this one, I'm defining the implementation of the method, what is there in my base class, that method I have done the implementation over here. Okay. Let me explain. I mean, let us have the object being created from that class. So what you call the circle class. So, okay. So in the circle class, we are not defined the, we are not pass the values for that. So what I'll do is, I'll create the object, and through the object only I'll pass the data for it. So circle, so object I'm using C, it's equal to new circle I define. Okay. Right. I've defined the object called circle there. Now C dot, I'll use the radius. C dot radius is equal to 10, I'm giving it. Okay, then I'll call the area method, I'll call it. Okay, when I call the area method, it's going to call the, it is going to calculate the area, it's going to be calculated, and it's going to print me the value of the area there. So I'll just run my code. There is an exception, format specifier is wrong for us. Percentage float. Okay, I'll do one thing. For timing, I'll just use println only, I'll use. Okay, no issues in that. So now you see that the area is going to be calculated, area of the circle is calculated as 3.314, okay, something like this. So this is what it's going to do for me. The calculation of the area is going to be done. Okay, then it's going to do it. Let's go back to the, the explanation part I was just talking about. Now here we defined a class called shape class. We defined, it's an abstract class. And what are the common things are going to be there for me in my different classes that I have taken it, I have defined it here. But for the example purpose, when I'm just writing the example, So I have not taken the properties like x and y values. I have not taken it. I just removed it because we are not going to draw the method. Sorry, we are not going to draw the object. So I'm not using this xy values. I'm not using it. So I'm just taking only the methods I'm going to talk about. So in the methods also, I'll take the example of only the area method I have taken it. Okay. Right. So you understood now here how we are going to work with this abstract class. Now this is one abstract class. So you want to have one more class called the square or rectangle. You want to have it. So I want to define. I'll just do one thing. I'll just copy the same code. So what are the necessary changes are there that will make it right? I want to have another class called rectangle class. Okay, so this is also extended from the shape class, but this is going to be having its own values are going to be there. For the rectangle, I require the length and breadth are required for me. So how do you calculate the area of rectangle? So the area of rectangle is equal to the math.pi and all are not required for us. So it's a simple calculations. It is length into breadth it is. So the value is length into BR. Okay, length into breadth. So now my area of the rectangle, okay, area of my rectangle is the AR. I'm just printing it. Okay, so here we can have the integer value can be taken for it. Why? Because when I'm going to multiply two integers, I'll get the result is only an integer. So I can just have the integer value also can be used for this. So when I come on to the main part of the program, so what I'm doing is I'll create the object, the rectangle object. I'll create the rectangle class. Some object R is equal to new rectangle. I'm defining it. Okay. New rectangle class I'm defining. Then so I want to call the rectangle. I want to print the. I want to set the length and breadth values. I want to set. So I'll be writing length dot length is equal to some value 10 there. Then r dot br value is equal to 20. I'll make it. Then I want to calculate the area there. So then I'll call the a dot area function. I'll be calling it. So once I call this a dot area there, you will see that the area is also going to be calculated for me. Then you see that the area of rectangle is calculated as 200. So this is how we are going to do it in what you call the using the abstract classes. Okay. So any questions you have here? So anything that you are not understood? Any questions? So this is what we are talking about in the previous class regarding your abstract classes. So we have taken one more example for the abstract class here. Okay, this is how we are going to do it. Any questions here? Okay, now we'll talk about the interfaces. Now we'll talk about the interface part. I'll do one thing, I'll just copy this code. Okay, I'll just put into the notepad so that we can use it. I'll be uploading the same code, I'll be uploading it to my Google class. Okay, right. Now this is something about the abstract class. Now how about an interface? Now I want to define an interface. When you want to define the interface, now you'll use a keyword called interface. Okay, we use a keyword called interface. We'll be using it. Sorry, we'll use a keyword called interface. Right. Then what is the name of the interface that you want to define it? You define it. But when remember, when we said that in case of the interfaces, we have the methods without the body. That is, we have only method signatures will be there. So it is not required for you to define it as abstract. That is, by default, in the interface, you have the abstract methods only. That means without the body, only signature part will be there. And what is the another difference that we have it here? When you talk about the inheritance part, you can create a class from the interface. For that one, you have to use a keyword called implements. Will be using it. We'll be using a keyword called implements. Will be writing. So implements keyword, we are going to use it when you want to define a class from that. Okay, fine. Now here, so when I'm defining the class there called circle, I said that it is going to implement the the interface called the shape there, then the class, you can have your own methods and everything can be there. And in addition to this, and when I'm going to define this class called area class, sorry, area function, I'm defining it. It is better you define it as a public type. So the class in the interface, the shape, the method area is there, right? That area method is said to be weaker. I mean, that is said to be having an access modifier of default there. I'm not defining any access modifier for that one. Then it's always better you define in the subclass. In the subclass, you define the methods with the higher visibility. Okay, or what you call it as the public, you need to define it. Then, so how you are going to calculate the area and all, the part remains same here. So when you talk about the rectangle now, so rectangle also the same thing will do it. So instead of using extends, now here we'll be using a keyword called implements. Okay, I'm writing it as implements shape there. Everything remains same, but here you need to have with higher visibility here. So public is the higher visibility compared to the default. Okay, done. So everything is done same, everything is same for it. There is no change of this, right? And the differences between the abstract classes and interfaces means, so in case of the abstract classes, you can have the methods with the body also, but whereas in talk about the interfaces, you cannot have the methods with the body. It will not allow us to have it. Okay, this almost all the concept remains same for me. I'll just run my code now. So you see now the area of a circle is calculated, area of a rectangle is also calculated for me, and we are going to see them. Okay, right. Okay, when you talk about the interfaces, so we are going to use a keyword called implements. We are going to use. Right. Okay. So when you talk about the abstract class, so for in inheritance, what you do, use a keyword called extends. Will be using it. So when you talk about the interface, okay, then we are going to use a keyword called implements, right? Okay, understood. So then when you talk about the abstract class can have both the methods are available for me. You can have the method with body, without body can be there. But whereas when you talk about the interfaces, you cannot have the methods with the body are not allowed for us. Okay. So just run the code and check. Okay. So yeah, it's working for me. The both it's working. Now, let me explain you something different now. Yeah. So we have a concept called polymorphism. So what do you mean by polymorphism? Means polymorphism is a concept where poly means it says more than one. Okay, poly means it's more than one. So polymorphism means many forms. We have one object will be there. So that object is having different kinds of behaviors. You're going to have it. Okay, so we are going to have different behaviors will have it, or it is different. I mean, when you talk about the polymorphism, it is you have one object will be there, so that object will be behaving differently, or what we call it as, we have the methods will be there. I have a method. When I call that method, it behaves differently based upon the context. Able to understand? The best example, let us say that you being a student, you are a student inside a classroom, and you will be a son inside your home. Okay, you have different roles will be playing it. What you call the behavior is going to be different for you. When you are home, when you are at home, the behavior is going to be different, and when you are in the classroom, the behavior is going to be different. And let us say that when you are with your friends, the behavior is going to be different. Okay, the behavior is not going to be the same when you are there in the classroom. The behavior is not going to be the same when I'm going there, when I'm going to be there at my home, or when I'm there with my friends, right? The behavior of, okay, you call it as an object, the behavior of the object will change based upon the context where you are going to work on. For example, we'll say that I'm going to define, okay, a class called you can have an interface, or you can have the abstract class, anything, it's no problem for me. Now I'm going to define a class called shape class. I'm going to define it, or I'm defining an interface called shape, okay, in which I'm going to have the methods like move method is there, and draw method is going to be there for me. Now I want to define the class called triangle class. I'm defining it from the class called the shape or interface, whatever you call it as, right? Now in that one, I'm going to define how the draw method is going to work and how the move method is going to work. I've taken it here example. So when it says draw method, it's going to draw the object for me. When I'm taking the method called move, it's going to have the moving, the object moving, it's going to be like maybe the rotation or whatever you call it as. I'll define one more class, okay, called a rectangle class. I'll be defining it. In that also, I'll be defining the methods like draw rectangle method, and then a move rectangle method. I'm going to define it. So when I'm going to have the concepts of this move and all this, so this will help me to define what you call how the rectangle has to be moved. It's slightly different. I'll be taking it. The coding is going to be different. So as we took the example, like where you are going to calculate the area there. Let us say one more you are going to have it. So pentagon you are going to have it. So for pentagon also you're going to have the different shape. The when you're going to talk about the pentagon, how you're going to draw the pentagon, how you are going to move them, all that is going to be different for me. Now here when I talk about the polymorphism here, so I'm having different methods are there. Like draw method is there, okay. Draw method is going to be different for different objects. You talk about the rectangle object, the draw method is different. When you talk about the draw method of your rectangle object, it's different. For triangle object, it's different. And for a pentagon object, it is different. Okay, right? You're able to understand what I'm telling. Now, for the different objects, I'm having different behavior is going to be different for me. Let's go back to the code now. Yeah, right. I'll just do one thing. I'll just copy this code part. I'll just put it into my notepad so that same thing can be shared for us. Now, this is using the interface. I'll put the code, I'll paste it out. Now we'll talk about something what you call the polymorphism now. So we said what polymorphism. So what is this polymorphism for me? 1 second. So what is this polymorphism for me? So polymorphism, so one object, or maybe it's a single object, or you have the multiple objects, the behavior is going to be different for us. Now here I'm taking the interfaces, I have taken it, okay, we'll talk about them. So I'll go to the main part of my program. In the main part of the program, what I'm doing is I'm creating the object from the base class. So okay, here we have the interface, shape interface is there. So I'll create the shape. Now remember that as we said, in case of the abstract classes, in the interfaces also, you cannot create the instances of the interfaces, cannot be done. So I can, but I can create the reference. So this is going to be acting as my reference. Okay, this is acting as a reference for me. Then okay, I created a reference from the shape class. Then so what I'm doing, I have created the instance of the object class, I mean circle class. I have created the instance. Okay, I'll not call this area, I'll not be calling it. Now I'm creating the object of the rectangle class also, but I'll not call the area here. Now what I do is I'll the shape reference what you have created for this, I'll be assigning the data of the circle object. I'm assigning the data of circle object. Now here what we did, so we are assigned data of instead of saying the circle object, I'll say this is a subclass. Okay, I'm assigning the data from the subclass to this. Then I'll call the s dot area method. I'll call. Okay, I'm calling the s dot area method. That is, I'm calling the method of circle there. Okay, it's a circle method, right? Okay, then I'll take s is equal to r. I'm writing. That means I'm trying to assign again the data of a subclass to the base class object. Now I'll call s dot area method. I'll call it. Now when I call the area method here, so in the code you'll see now this is going to call the rectangle. Okay, so the rectangle area it's going to call for me. Okay, the circle method, or what my circle area method is going to be called for. Okay, so I'm going to have the circle area, I'm going to use it there. Now let's see the output, then we'll understand. Once again, I'll explain you out. Now you see here, if you look in the line number 40, I'm calling a area method there. In line number 42 also, I'm calling the area method. I'm calling the area method twice there. So one is s dot area. Again, I'm calling the s dot area. Okay, I'm calling the same method s dot area here. I'm calling in line number 42 also. I'm calling the s dot area. But when I'm calling that s dot area method, when I'm calling it here in this context, that is what I done before. I'm calling this area method. Assign the data of the subclass, that is a C object. I have assigned to s there, and then I have called the area s dot area. So the method which I'm calling here s dot area, and in the line number 42, both are same. Both are the same methods I'm calling s dot area and s dot area I'm calling it. Okay, when both the methods I'm calling the same method, I'm calling it. But if you look in, the output is going to be different for me. That is, when you talk about this s dot area here, so the first time when you're going to call it from line number 40, when you're calling it, it is going to print me the area of a circle. In the line number 42, when I'm calling it, it's going to print me the area of a rectangle. It is going to call. That means I'm calling same method, I'm calling it, but when I'm calling in the line number 40, it's going to give the behavior, or what you call its action, is different. And when I'm calling s dot area in line number 42, its action is different. How the action has been changed? The action is being changed based upon the context. So what is the context? So first I'm assigning the object of the circle class, then I'm assigning the object of my rectangle class. Now based upon the context, that is what the data that I have assigned, based on that data, it is going to call the different methods are going to be called. But I'm calling a same method, I'm calling s dot area, s dot area, but the output is different for me, or what you call the behavior is going to be different. So this concept is what you call the polymorphism, we call it as, right? It is called the polymorphism. That means based upon the context where you're going to call it, right? What data is being assigned to the object, and then you're calling it. Based on that, what will happen? The output is going to be different. So this is what you call it as the polymorphism, it is called, right? Any questions? Any questions here? What is exactly the polymorphism? Hmm. The same thing, you can also do it using the abstract classes. Now let us say that you don't want to have the interfaces, you don't want to have. So I want to have the abstract class. You can take the abstract class. So we'll take the abstract class called the shape. We know that when I'm going to have the abstract class, so instead of using a keyword called implements, we use a keyword called extends there. Okay, then everything remains same, there is no change in that. So here, instead of using implements, we'll be using extends. We know that objects cannot be created from the abstract classes, but references can be created. Now this is objects. So this is an object for me, right? It's going to have its own memory and everything. The rest of the thing remains same for me. Okay, I'll just run my code now. You see now it's going to call the area method, area method of your circle object and area method of your rectangle object. So this is the example, okay, with the abstract classes. Okay, so any questions you have it, let me know. So I'll just copy down both to the notepad. So this is using the classes. Okay, that is I'm using the abstract method, I'm going to use it. So this is one example for the polymorphism. Getting it? Now let us say that you have one more example you want to talk about. Now let us say that I want to have one more example. I want to talk about, let us say that you are going to define it. You want to write an application for different types of animals you want to write. Like for example, let us say cat, you want to, instead of circle, now let us say we talk about this one as the object called a cat. You're going to have it. So I'm going to talk about object called cat. Now let us say that I talk about one more object called dog. Okay, if we talk about one more object called bird, sorry, okay, instead of bird, let us say that I'm going to talk about an hen. I'm going to talk about, right? Now first analyze it. What are the things that you want to have it? For a cat, what are the data that you want to have it? Okay, you can have the methods like eating, sleeping, jumping, like that methods you can have it. For dog also we have eating, sleeping. For hen also we have eating, sleeping. Okay, right, like that. Okay, now when I talk about this, the cat object here, it will have its own data will be there. What is the height, what is the weight of it, okay, what is the color, like that. So almost all the data remains same for all these objects, right? Then you can just analyze it. What is that I need to do it, what are the things are different for me. Okay, so what you can do is you can just analyze how we are going to work with without inheritance and how we are going to work with using inheritance. You can talk about that one. Okay, you can try to have this example. So try to analyze this example. Or let us say that I want to write the programming for a vehicles I want to write. Okay, so I want to write a program for a two-wheeler. Okay, two-wheeler, three-wheeler, four-wheeler, I'm going to have it. Okay, so you can define the classes, different classes. You can define two-wheeler class, three-wheeler class, four-wheeler class. You define it. Then you write down what are the properties, what are the methods that will have it in all those methods, in those classes. Then you can start analyzing it, and then you can define what has to be done in the interfaces when you're talking. When you talk about the inheritance part. Now, how I can, what are the data that is common for me? You can remove that one and you can put into one common class called vehicle class, and then you can have the different classes like two-wheeler class. What are the things that you want to have it in two-wheeler class? What is the extra that you want to have it in three-wheeler class, four-wheeler class? Like that, you can have different objects can be created, and then you can have the programming can be written. So you can try different applications. You can try different examples. You can try, and then you have any difficulties in the examples, you can let me know it. Right? Okay. So any other questions?